Hello friends, welcome to Chemistry Nuggets where you can polish your knowledge and clear your doubts. Friends, today's video topic is nucleophiles and electrophiles. What are these, where the uses of these things and what are the properties of these things we will discuss in this video. So let's start the video, but before starting, if you haven't subscribed the channel, please subscribe the channel so that you will get the notification for the new videos. So let's start. So friends, when the organic reaction starts with the heterolytic cleavage, there will be a substrate and a attacking agent. When the attacking agent attacks on the substrate, there will be intermediates that will proceed to the final product. So here the substrate is the thing which has to be changed. And what are the attacking agents? Attacking agents are the nucleophiles or the electrophiles. So things which are used as an attacking agent are nucleophiles and electrophiles. So friends, as we learned that in heterolytic cleavage, there will be either cation will form or anion will form. That will depend the attacking agent which will be used in the reaction to proceed. So let's start with the nucleophile. These attacking agents are of two types. Either it will be a named nucleophile or it will be a electrophile. Let's have a look on the nucleophiles. Nucleophile simply means nucleus loving, or we can say nucleus seeking. So a nucleophile is a species that is searching for the nucleus. Let's have a look on the definition. A nucleophile is a chemical species which brings an electron pair. So such a species which is having electron pair with it, it's called a nucleophile. For example, hydroxide ion. See here it OH minus. Minus indicates that it has a pair of electron. In the same way, cyanide ion Cn minus. Minus indicates that it is having a shared pair of electron. Rc, R3C. These are the carbon ions having minus charge and a shared pair of electron. In the same way, some neutral molecules also behave like a nucleophiles. How? Because we knew that in the water molecule, oxygen is having a pair of electron which is unused. This unused pair of electron, it will use as a electrophile, sorry. This unpaired electron, water will use as a nucleophile to attack the carbocation. In the same way, R3N is having a pair of electron which is unshared and unused. Same R2NH also having a pair of electron. So a neutral molecule which is having a pair of electron with it, which is unused, or a negative charged ion, both will behave as a nucleophile. Let's have a look on the properties. The first property of the nucleophile is it always brings the electrons. Second thing is nucleophile is denoted by the Ne and a pair of electron. Third point is these nucleophiles are always electron rich. Fourth property is It always attacks the electrophilic center of the substrate. Attacks the electrophilic center. The fifth point that should be mentioned is the reactions which proceed through nucleophiles are called nucleophilic reactions. So this is the story of nucleophile. When there is a carbon species having plus charge, the nucleophile will attack on that carbon and make the product. Now, the other type of attacking agent is electrophile. As the name suggests, electrophile means electron loving. You can write here electron loving or electron seeking. So the name suggests a species which is searching the electron. So it will be a deficient in the electron. Let's have the look on the definition. A chemical species or a reagent that takes away the electron pair is called as electrophiles. So the species which is deficient in electron always searching for the electron to take. That kind of species is called electrophile. The example should be carbocation. So the example basically should be all plus charge species. Plus charge means electron deficient. So all the plus charge species will behave like a electrophile. And some neutral molecules that I will explain you later. First, see the plus charge ions. Methyl carbocation is having a plus charge, that is sextet of electron. So it always search for the attacking agent which will give the which will give the electron. So it always attached with the electrophiles. In the same way, NO2 plus is also having a plus charge and it behaves like an electrophile. Neutral molecules with a functional group like carbonyl group and alkyl halide. So carbonyl group we can say C double bond O is there. Oxygen is having high electronegativity in compared to carbon. So there will be a partial shifting of electrons toward oxygen and the whole compound will become polarized, and the carbon here is behaving as having plus charge. In the same way, when there is an alkyl halide, some we can have like this. Here the chlorine is being highly electronegative. There will be a partial shifting of shared pair of electron towards chlorine so that the carbon center become positive, having less carbons, and the whole compound will behave like a cation. That's why some of the neutral molecules having the parts having different electronegativities will behave like a carbocation, or we can say the positive charge ions. So this is the story of electrophile. Let's have a look on the properties. The first property is it always takes away the electrons. Second property is it is denoted by the letter E and plus charge. The third property is it is a electron deficient species. Fourth point is the electrophile always attack the nucleophilic center, or we can say the electron center. Attacks the nucleophilic center, or we can say simply the electron rich center. Fifth point is the reaction proceed through electrophiles are called electrophilic reactions. So this is the story of nucleophiles and electrophiles. They are used when the organic reaction proceeds through heterolytic cleavage. They behave like a attacking agent. When there is a positive charge ion, the nucleophile will attack, and when there is a negative charge ion, the electrophile will attack. This is the whole story. Hope you guys understand. If you have any doubt, you can write a comment. Till then, keep studying and ask the questions. Thank you. Bye.